Hey there, this is Math 8, Unit 5, Lesson 13, called the volume of a cylinder. Let's explore cylinders and their volumes. Alright, first of all, we have a little picture here, and it's called a circle's dimensions. We have a circle. We have a diameter going across from C to B. We also have a radius here of 4. So what we can tell from this picture so far, what we know at least, is that we have a radius equal to 4, which would mean we also have a diameter is double that, equal to 8. Now we don't know if we need that yet for our questions. We're just taking a look at what we see in the picture. It's always good to look at the picture and just kind of point out what you know. What do you notice? What do you wonder? What's going on there? And then let's apply that to what we see down next. So it says here's a circle with points A, B, C, and D are drawn, as well as segments AD, BC. What is the area of the circle in square units? And select all that apply. Well, we need to recall our area formula for the area of a circle. The area is equal to pi r squared. So the value of pi times the radius squared. In our case here, our radius was 4. So if we were to put that in there, we'd say pi times 4 squared. And 4 squared is 16, so it'd be pi times 16. And these are ways to write out what our area is going to be. So now when we take a look at our options here, we can see we have options like 4 pi. Well, that's not going to work. We need 4 squared pi, so that's not going to be a good one. Pi 8, nope, that's there in case you thought this is 4 times 2, which it's not, so that's not going to work. 16 pi, or pi 16, right? We could write this the other way and just change the order. That's going to be just fine. And then pi times 4 squared, which is here, it's exactly the same thing. We have approximately 25. Well, where's that coming from? That comes from taking your 16 pi and saying, well, let's go ahead and multiply that by, about 3.14. So if you multiply this by 3.14, that's our approximation of pi, what would you get, right? So 6 times 4 is 2, 6 times 1 is 6, plus 2 is 8, and then 18. And then we do 0 there. 1 times 4 is 4, 1, and 3. When we add those up, we end up with 50.24 to find the decimal. And so in terms of our actual area, we would say it's approximately 50, not 25. Number 2. It says here, if the area of the circle is 49 pi square units, which is about what we got there, what is its radius? Well, this is a different question, I should say. So what is its radius here? So if the area is there, what is the radius if it's about 49? Well, let's think of it this way. If the area is going to be equal to 49 pi, we know that in terms of our formula, to get to the area is equal to pi times a radius squared. So the pi is already given to us here, and the area is given to us here. And then we have this number, 49, which is going to be our radius squared. The question is, what's the radius by itself? So we have to ask ourselves, what number times another number gives us 49? And so knowing your math facts, we recognize that 7 times 7 is 49. So that's what would go right here as the 7 squared times pi, and the radius then is equal to simply 7. And that's what we would do there. So think through how you got there, but I used the formula and kind of worked backwards a little bit in order to arrive at the radius of 7. In the next activity, we're looking at circular volumes. It says, what is the volume of each figure in cubic units? Even if you aren't sure, make a reasonable guess. And that's just fine. We're just taking a reasonable guess here to see how close we can get and what do we know about different volume measurements. So notice here that we have in the 3 shapes, they are highlighting or shading in one face of each of these shapes here, right? And so what we're doing is we're saying, well, we have a base here, 8 by 2 base. And then here we have a base of a circular base with a radius of 4, another circular base with a radius of 4 there. All right. Figure A says a rectangular prism whose base has an area of 16 units and whose height is 3 units. and we can see this being 1, 2, 3. We take this base of 16, okay, that's our base, and we're going to multiply that by the height. Now in this case here, the base would already gave us as 16, and the height was 3 units, so that's going to be 3. So 16 times 3 is going to be 48 units. In this case here, it's going to be units cubed, if we were to be accurate there, because it's volume. We have the base times that height. In the B, we're going to take the area of that base. Well, in this case, the area is going to be pi r squared times the height. And in our case here, this is pi times the radius 4 squared times the height of 1. So that simply becomes 16 pi. How do we get 16 pi? Well, 4 squared, 4 times 4 is 16. 16 times 1 is still 16. And then 16 pi is just 16 pi units cubed. For this one, we have the same base, right? There's our pi r squared, which we already know is 16 pi. So we have our base still times our height. In this case, we know our base is 16 pi from a previous problem, but our height is now 1, 2, 3. So we're going to multiply that by 3. And 16 times 3 is 48 pi units cubed. So you notice this one here is 48 pi units, this one's 48 units, so there's a difference. Even though they're the same number, this one also includes the value of pi, which makes it quite larger. Alright, I'm going to skip the Are You Ready for More today. I'm going to move over to 13.3, which is about a cylinder's dimensions. In this problem here, it asks you to sketch a radius and the height, label the radius with an R and the height with an H. So in this one here, I'm going to go ahead and plot a point right there, and I'm going to sketch a point here that we're going to call radius, and then I'm going to call this long part right here my height. Here I'm going to plot a point in the middle and go across and call that my radius, and I'll call this long part right here my height. For the rolled oats, the oatmeal again, I'm going to draw a line there, call this my radius, and I'm going to call this part right here, from here to here, that's my height. For D, it turns a little bit sideways, that's okay. I'm going to put a point in the middle of the circle to make a radius, and in this case, this becomes my height. It's just the same as before, it's just a little bit crooked, isn't it? Over here we have this like a water truck of some sort, so we probably have a radius that goes in the round part there, but the height is going to be the length. Hard to see this here, I'm sorry. So the height is going to be how long that's going to be. And just like here in the silo, if you were to kind of put your dotted lines through there, you have a radius about here, and the height is the height of the whole tower there. Earlier it says you learn how to sketch a cylinder, so sketch E and F and label the radius and height. So in this case here you have a cylinder on its side like this. Draw 2 circles and connect the edges. So you're going to put a radius here, and you put your height there. And over here we have a circle and a circle. Connect the sides, and again a radius and a height. And that's the idea there for just sketching out those dimensions. Here's a cylinder with height 4 and a diameter 10 units. First of all, it says to shade the cylinder's base. So we're going to shade this part down here. And there's the base of our cylinder. What is the area of the cylinder's base and expressed in terms of pi? Area, we've said before, is equal to pi times the radius squared. In this case though, be careful, they gave us a diameter. Okay, and a radius is going to be half of that. 10 divided by 2, which is 5. That's going to be our radius. So for our B, we're going to say it's pi times 5 squared, which is 5 squared is 25, and we keep pi just like that. So our area is 25 pi. What is the volume of this cylinder? Again, volume is going to be the area of the base. So the area of the base times the height. In this case here, it's 25 pi times the height, which is located right there, 4. 25 times 4 is 100, and we just keep pi like it is, and that becomes our volume, is 100 pi. A silo is a cylindrical container that is used on farms to hold large amounts of goods, such as grain. On a particular farm, a silo has a height of 18 feet, diameter of 6 feet. Make a sketch of the silo, label height and radius, then how many cubic feet of grain can it hold. So let's figure out its volume there. Alright, and we're using 3.14. So we have a silo that has a shape like this, right? We know it has a diameter of 6, and it has a height of 18. So we're going to take the area of the circle, which is pi times the radius squared, and we're going to multiply that by the height. In our case, we know pi is equal to, they want us to use 3.14, so we'll put 3.14, and we're going to multiply that by the radius squared. The radius is half of 6, which is 3 squared, and then we're going to multiply that by the height, which is 18. So we have 3.14 times 9 times 18. And when I multiply that out, 3.14, which is pi, times the radius squared times the height, I ended up with 508.68. Now if I want to round that up, I would say that's about 509, and we're doing cubic feet, so that's going to be feet cubed as our amount of grain that silo can hold. And that's the idea. So we're learning how to take the area of the base of an object, multiply by the height to determine the volume of a cylinder, or any kind of shape for that matter. So let's take a look at our summary real quick before we go into our homework. Okay, so just remember that a volume of a rectangular prism is the result of multiplying the area of its base by its height. And we want to do that same thing when we're talking about the volume of a cylinder. We find the area of its base, whatever that might be, and we multiply that by the height. So in general, the base of a cylinder, radius r units, has an area pi r squared, and if it has height is h units, then the volume in cubic units is volume equals pi r squared times h. Alright, I'm going to pause there and let's do your homework and then come back together to check it in just a few minutes. Alright, here's your homework tonight. It says match each set of information about a circle with the area of that circle. Alright, so we have over here 4 pi, 314 square units, 64 pi, and 16 pi. Alright, circle A has a radius of 4 units. We're talking about the area stuff. So, if it has a radius of 4 units, that's going to be pi times the radius squared. If the radius is 4, 4 squared is 16. That's going to be 16 pi. That seems to match number 4. Right? So we're going to go down here. It's going to match number 4. That's what we got for that one. For B, B says has a radius of 10 units. So the area is equal to pi times the radius squared. Well, 10 squared is going to be equal to about 100. All right? So we have 100 times pi. I don't see 100 pi anywhere, but I know that 100 times 3.14 is approximately 314. So we're going to say that's the best choice right there. C, We have a diameter, be careful, of 16. So we got to cut that in half to make it equal to 8, right? Cutting it in half to make the radius. So pi times the radius squared. 8 squared is 64. I'm going to leave the pi where it is. And 64 pi matches number 3 right here. And finally, circumference of 4 pi. Now we already know the answer is going to be 1, but let's see how we get there. Circumference equals, remember, 2 pi r is how you find circumference. Or you can think of it as pi times the diameter is what circumference is going to be. In our case, it said that circumference is equal to 4 pi. I'm going to write it as pi 4, okay? Just so we can see that our diameter happens to be 4. If our diameter is 4, that means that our radius equals half of that, which is 2. So to find the area is pi r squared, or pi times 2 squared, which is pi 4, or also written as 4 pi. So that's how this is going to be number 1. Okay, number 2. We're going to sketch a cylinder, label the radius 3 and the height 10, and shade one of the bases. So here we have a cylinder, something like this. We're going to give it a radius of 3, a height of 10, and we're going to shade one of the bases like that. And that's it for number 2. Number 3 is a great problem here. It says, at a farm, animals are fed bales of hay and buckets of grain. Each bale of hay is in the shape of a rectangular prism. The base has side lengths of 2 and 3 feet. So we have a 2 by 3 feet base. So 2 by 3 foot base for the bales of hay, but the height is 5. Okay, so 2 by 3, but it has a height of 5. The grain cylinder, each bucket of grain is a cylinder with a diameter of 3 feet. So we know we got 3 feet there, 3 feet across, and the height of the bucket is also 5. So that's our grain in the rectangular thing with this base there, and then we have our rectangular, our cylinder base right there. Which is larger in area, the rectangular base or the circular base of the bucket? Talking about just the area. So the area of the rectangular one, right, that's a rectangle. Rectangle is 2 by 3, so 2 times 3 is equal to 6. Now in terms of up above for our circle is going to be, we have a circle with a diameter of 3. That makes our radius equal to 1.5. So the area in that case is area equals pi times the radius squared. 1.5 times 1.5 is equal to 2.25. 2.25 times pi. That's our area there, right? So times pi. And pi is 2.25 times 3.14, which is equal to about 7.065. So I have a 6 over here for the rectangle and a 7-ish over here for the circle in terms of the area of the base of each shape. So which one is larger? We would say the circle is the larger area. Because it's a larger area, the question then is which is larger in volume. Because all I'm going to take is the area of the base, multiply that by the height, I can determine which one has a larger volume right away without even doing any math. Why is that? Well, because this has a height of 5, this has a height of 5, so I'm going to be multiplying either 6 times 5 or 7-ish times 5. And so which one's going to have the larger volume? The one with the 7. The circle one's going to have the larger volume because it has a larger base. In this case here, that circle one's called the bucket, right? So the bucket is going to be the big winner for the most volume. Number 4. 3 cylinders have a height of 8 centimeters. Cylinder 1 has a radius of 1, cylinder 2 has a radius of 2, and 3 of 3. Find the volume of each. Okay, so to find the volume, it's going to be pi times the radius squared times the height, right? That's our basic formula here for the volume. So we have pi times the radius of 1 squared times the height, which is 8. So that's 8 times 1, which is 8 pi. We also have pi times the radius squared, which is 2 squared times 8. 2 squared is 4. And then 4 times 8 is 32. So we'd say 32 pi. And then finally pi times the radius of 3 squared times 8. 3 squared is 9. 9 times 8 is 72. So we're left with 72 pi. So I have 8 pi, 32 pi, and 72 pi when the radius are 1, 2, and 3. Alright, a 1-quart container of tomato soup is shaped like a rectangular prism. A soup bowl shaped like a hemisphere can hold 8 ounces of liquid. Alright, so we have, first of all, a quart of soup, 1 quart right there. And then we have a soup bowl like this that holds 8 ounces. Recall that 1 quart is 32 ounces is what's in here. How many bowls will the soup container fill? So if this is 32 ounces, how many times can I fill up that bowl, or how many bowls can I fill to make that work? So I'm going to take 32 ounces and I'm going to divide it into bowls that are 8 ounces large, right? This is 32 ounces divided by 8 ounces. The ounces cancel out. 32 divided by 8 is 4. So I end up with 4 bowls of soup is what I can pour the quart into. 4 times 8. And finally, number 6. 2 students join in a puzzle solving club and get faster at finishing the puzzles as they get more practice. Student A improves their times faster than student B. So A is going faster. Faster is going to mean it has a steeper rate or a steeper slope because it's going to be faster, right? It's doing more in less time. So which one has a steeper slope? The steeper slope is going to be here at L. This is going to be student A. And a little bit slower slope right here is student B. So there's our matching of lines L and M. Which student was faster at solving puzzles before practice, right? Make sure you're reading there. Before practice. We know that after practice, student A is faster, but before it started practicing, right? Look at the thing here. It took this person only 5 minutes to do a puzzle, and this guy took 6 at the beginning. So person M, which is student B, was faster to start with, but by the end, we see here student A is able to solve it in 3 minutes, when before it was 6. That's a great improvement for that student. That's it for today, and we'll see you next time.